Science Magnificent Morning, Science! Kumusta? I am Sir D, ang Science Terrific Teacher ng Grade 8, here to help you with your modules for Week 3 and 4. Today, we are going to embark on a journey of discovery, for we are going to learn all about the atom. Before that, let's test your prior knowledge. I have 2 questions. Try to answer them all by writing your answers on the piece of paper or by memorizing it. Are you ready? Let's begin! Question number 1. Democritus is a Greek philosopher. What was the term used to describe the atom? If you answered atomos, you are correct. Question 2. What are the 3 subatomic particles? Good job! Those are the protons, neutrons, and electrons. Excellent work! If you got all correct answers, give yourself a pat on your shoulder. You did well! Let's begin with today's main lesson. This is what an atom looks like. It is mostly composed of an empty space, but it is considered to be the building block of matter. The atomic model underwent a lot of changes as many scientists studied them and as technologies evolved. We have John Dalton's solid sphere model, J.J. Thomson's plum pudding model. We also have Ernest Rutherford's nuclear model. And lastly, we have Niels Bohr's planetary model. Now, let's talk about the different atomic models proposed by this magnificent scientist. According to John Dalton, he viewed the atoms as solid spheres which he believed had 4 characteristics. Number 1, atoms are tiny invisible particles. Number 2, atoms of an element are all the same. Number 3, atoms of different elements vary from one another. And number 4, atoms may form compounds when combined together. These findings and postulates of Dalton paved a clear way for the discovery of the subatomic particles. J.J. Thomson proposed that the atom is a positively charged sphere with negatively charged particles called electrons held by attractive forces between the 2. He presented it as the plum pudding model, or most commonly known as the chocolate chip cookie model. Yum! On the other hand, Ernest Rutherford described that the atom consists of dense spores called the nucleus, with a positively charged particle known as the proton, while electrons surround the nucleus. He called this as the nuclear model of an atom. This model is what we were most familiar about when we talked about atoms. A few years after, Niels Bohr improved the idea of Rutherford by proposing that electrons are not stationary as they move around the nucleus in a fixed circular orbit known as energy levels. He called this the planetary model. He got the inspiration from our own solar system. There we have it. Those are the 4 significant advances to our atomic theory. For our next lesson, we are going to learn how to compute for the number of protons, neutrons, and electrons in an atom. For you to have a clear understanding, let us have here the symbol key of an element. X represents the chemical symbol, A represents the mass number, and Z represents the atomic number. In determining the number of neutrons and protons in an element, we will be working on these formulas. The mass number is the sum of the number of protons and number of neutrons. For neutral atoms, the number of protons is equal to the number of electrons. The number of neutrons is the difference of the mass number and the atomic number. The atomic number is the number of protons in the nucleus. For example, we have the element C or carbon. We will compute for the atomic number. Since there are 6 protons and electrons, the mass number is also 6, since the number of protons is equal to the atomic number. Since 12 is the mass number, we need to find the number of neutrons. For us to find it, let's use this equation. 12 is equal to 6 plus n, let n be the number of neutrons. Transpose the number 6 to the other side of the equation for us to get the number of neutrons. Thus, it will become 12 minus 6 is equal to the number of neutrons. Thus, the number of neutrons is 6. Next, we will have another example. Let's have the element sodium, and we will look for its mass number. Now let's try sodium or Na. The atomic number of sodium is 11. Thus, is it equal to the number of protons and electrons. Let's find the mass of sodium. Let's use the equation A is equal to B plus N. Thus, 11 plus 12 is equal to the mass number, which is 23. Since we can determine the mass number of an element by adding the number of protons and neutrons. Studies on the masses of atoms show that atoms of the same element may have different masses. Such species are called isotopes. Isotopes have different mass numbers, thus they also differ in the number of neutrons. However, an atom may have a charge. If an atom has more electrons than protons, then it becomes negatively charged. If the atom has less electrons than protons, then the atom becomes positively charged. Charged species are called ions. Let's summarize all that we have discussed. The building blocks of matter are atoms. Atoms are composed of subatomic particles, protons, neutrons, and electrons. Particles of unlike charges attract, and particles of like charges repel. Some significant atomic theories are Dalton's atomic theory, Thomson's plum pudding model, Rutherford's nuclear model of the atom, and Bohr's planetary model. Atoms of the same element can have different masses due to the differences in their number of neutrons. We call these substances as isotopes. Isotopic symbols are used to distinguish isotopes. Atomic number is equal to the number of protons. Mass number is equal to the sum of the number of protons and the number of neutrons. And that's it for today. I hope you pick up some information as you were watching. I appreciate your effort and reaching out to the end of the video. Always remember, in this world of electrons, be a proton. Till next time, see ya!